Hello, everyone. Welcome to Innovator Coffee, the podcast that bridges the gap between people and the world of AI and innovation. Follow us to explore the top AI products, ecosystem insights, and the emerging trends. For this episode, we features an engaging podcast interview with Dr. Chary from the MIT Media Lab, focusing on the rapidly evolving landscape of AI agents and their communication protocols. The discussion centers on MCP, explain its role in enabling large language models to interact seamlessly with various tools and services through a standardized JSON RPC schema. While MCP primarily facilitates agent communication, the conversation also introduces product Nanda, an MIT initiative aiming to establish an open, decentralized web of AI agents by addressing critical aspects like agent discovery, reputation, security, and traceability, ultimately fostering collective ecosystems for networked AI. So, enjoy.
Hey, hi everyone. Thank you so much for having me here. It's a great pleasure. My name is Dimitry Chary. I am a researcher here at the MIT Media Lab, working with Professor Ramesh Raskar and the Decentralized AI group here at MIT. I did my PhD from UCLA in AI and computer vision. And most recently here at MIT, I'm working on a range of projects in the space of decentralized AI, networked AI agents, and I'm sure we'll talk about a lot of that as part of our chat today. Very excited to be here. Thank you so much.
Yeah, thank you for coming. Actually, in Silicon Valley recently, a lot of tech people are talking about MCP, the protocols. Yeah, last time I talked with a program from OpenAI, and I say that even OpenAI will dip into the MCP given that this is from Anthropic. They say, yeah, it's interesting. So we are very excited to have you here. Can you introduce what inspired?
So for example, if you want to call an API or do a database call or something like this, these agents need to have the ability to invoke tools. Before MCP, this was still possible, and it's still possible by other companies like OpenAI and so on and so forth. And the way it was done was using custom context passing and by using what are called as function calls from agents, where each new function had to be customized within the prompt or the training of the agent, and the agent was cued to call the function using a certain JSON schema that is specific to every function. So every new tool that the agent had to call, you had to somehow program that within the context of the LLM to enable it to call that tool. With MCP, the amazing thing that MCP did was created a one solution that fits all different kinds of APIs or databases or functions by giving what's called a JSON RPC schema, where any tool, any resource, any prompt, anything like that that needs to be called by an LLM can fit within this JSON schema that MCP provides. And it's almost a USB-C port for LLMs to connect to any tool that's out there. What's very cool is that the person who's deploying the LLM doesn't need to know what kind of tools this LLM will be using in the future, because everything fits within this MCP schema. So it allows for a lot of interoperability. And yeah, that's, I believe, the inspiration behind creating MCP from Anthropic.
Cool. So why do you think the MCP important in scaling safe and decentralized multi-agent AI systems?
Yeah, I think that's a great question. As I mentioned before MCP, for LLMs to connect to tools or indeed other agents, it had to be manually or it had to be intentionally programmed within the context or the fine-tuning of the LLM or within the system prompt, for example, that this LLM has to deal with this particular tool, and to do that, it should do it in this particular way, given a particular schema. What MCP has allowed, as we discussed just now, is a standardization. Any LLM can scale to any number of tools, resources, agents, whatever you call it, without it knowing what is the agent that it has to talk in the future with. So given this context, now the strength of MCP is that it has provided a standard method for agents to maintain and exchange context with each other for tasks. And it allows for easy scalability because LLM builders and tool builders don't need to talk with each other about a fixed schema. Now, LLM builders have this MCP schema that they have to adhere to, and tool builders have this MCP schema that they have to adhere to. And this sort of very nicely solves this two-sided marketplace problem where they don't have to talk to each other and they just have to adhere to one schema. Given this, now this is a very amazing thing for scalability because everyone adheres to this schema and it almost acts like a foundational protocol and infrastructure that everyone can build on top of, and it allows for very quick and easy scalability.
These days, when you search on internet, there are many MCP servers out there, right? So could you explain what does these MCP servers mean then?
API call is split into functions. So let me give you an example, a very simple example. Let's say I have this nice API that allows me to query weather through like a weather API service, right? And this API has two functions. I can get like alerts for a particular area, for a particular state, or I can get the weather forecast if I give a particular location. Now, let's say I want to interface this with my LLM. So for example, I want to ask the LLM the question. So I am right now in Boston. I want to ask it the question, what's the weather going to be in Boston in 1 week? Now, if I ask this LLM the question, if I ask Claude or ChatGPT or any of these LLMs this question, without giving them access to tools, they'll just say, oh, I don't have access to real-time weather. But instead, what MCP does is it wraps around these two API functions within a nice wrapper. And very crucially, it provides a textual description for what each function does. And it provides a very nice JSON schema saying these are the inputs that you should give to this function. And these are the outputs you should expect from this function. And this is the textual description. So what this does is the LLM now knows this is what this function does in natural language. And this is the structure in which I have to give this LLM, give this tool the input. And what the MCP server does is this, it takes the JSON schema that the LLM provides, and it translates that into a bunch of function calls via the API. And the API returns the output of this function call. And the MCP server again wraps the output of the function call in another JSON schema that goes back to what MCP has done, or what all of these MCP servers that exist out there are doing is wrapping API calls or function calls with this JSON schema and textual description so that LLMs can use it.
I see. Besides, there are similar protocols proposed, and what's the difference between a function call plus other similar protocols there?
Great question. Great question. So I think we really are in what a lot of people like calling the protocol wars. So there are so many amazing protocols that are coming up almost on a weekly basis. Some sort of common ones are A2A from Google, ANP, ACP from IBM, and so many others that are existing out there. And I'll try to touch upon all of these. So first off, up top, you mentioned function calls and how they are different from MCP. Is that MCP, in a sense, is a generalized function call, which means MCP enables to do all kinds of function calls with a fixed schema, whereas function calls before MCP required that every unique function, such as this weather function or a browser search or some third thing, would have to be individually structured in its particular JSON schema by the LLM builder to enable the LLM to talk to that particular function. So function calls were one by one, whereas MCP allowed all of these function calls to be bracketed into one specific schema that plays a massive role in scalability. Now going back to common protocols such as ANP and ACP, which is Agent Communication Protocol, and A2A by Google, which is agent to agent, they all actually focus on agent to agent communication, whereas MCP, it is very important for us to understand, is focusing on agent to tool communication. So let's think about this aspect for a few minutes. When Anthropic built MCP from the perspective of Claude, the goal of MCP was to improve the context of the model, which is the LLM, to help it make better decisions or help it perform better tasks. So Anthropic, very rightfully, was looking at MCP from almost a hub and spoke model where the LLM is at the center and all tools and resources that are available out there are at the boundaries. And the goal of MCP is to bring all of these tools within the context of the LLM so that the LLM can take better decisions. MCP is enabling this agent or LLM to tool interaction and enabling that at scale. And it's done an incredible job at that because MCP is extremely general and it's very lightweight, which enables people to design their own kinds of MCP servers that do a wide variety of things. For example, you can build Spotify MCP servers that you can use to control your Spotify on your MacBook via Claude. You can build Blender MCP servers by which you can type in your Claude LLM and it will create 3D models. And you can also do fun stuff like API calls, as I was saying, or database calls. Now, all of these other protocols that are coming out, like ANP or Agent Communication Protocol or Agent to Agent by Google and so many others that exist out there, are focusing on agent to agent interaction, which is a very peer-to-peer structure. So MCP focuses on agent to tool. These are all focusing on agent to agent. And within them, they all have individual specialities that they are trying to focus more on. So for example, ANP is trying to focus more on the trust and discovery aspect by using aspects such as DIDs or decentralized identifiers to enable distributed agents to find each other, authenticate each other, and work with each other in a trusted environment. ACP is focusing more on the communication layer and enabling messaging between agents that are distributed. And A2A by Google is trying to standardize agent communication and discovery across organizations that work within the Google Cloud environment. One of the very important things that A2 Agent by Google proposes is this idea of agent card. So one very important thing as these agents scale forward is the idea of agent capability. How does an agent that exists out there advertise its own capabilities, say what it's good at, and say what it should be reached out to for what particular types of tasks? A2A by Google proposed this idea of an agent card, which is another JSON schema that explicitly identifies the skills of the agent, such as what tasks it's able to perform, what protocols it supports, what are the input-output schemas, some important things like this that enables stuff like this. So on a summary level, MCP is the agent to tool USB-C port that enables connecting LLMs to tools, whereas all of these other protocols that exist out there like ANP, ACP, A2A, maybe there exists like 3-4 more also, are all focusing on agent-to-agent interaction and how to enable that.
Why do we need agent-to-agent protocols? Shouldn't they just prompt each other? And does MCP also include the agent-to-agent, or it only focus on agent-to-tools?
Yeah, I have like similar question because from the technical standpoint, which is the next question on the technical component, right? It seems like they have a similar way to address the thing, right?
Yeah, so I think you've touched upon a very important point. I think two questions were asked over here. First is, can MCP enable agent to agent, or is it limited to agent to tool only? And second, why do you need agent to agent protocols? I think these are related questions. So to answer your first question, this is, and I will touch upon Nanda, which is the project we are working over here at MIT. And when we started working on Nanda at MIT, this is the question we asked as well, which is, we looked up all of these MCP servers that exist out there, and we saw that a large fraction of these are agent to tool. And whenever Anthropic advertises MCP, they're also focusing on the agent to tool perspective. But we asked the same question, which is that, does anything fundamental limit MCP from doing agent to agent? And we actually found that this is not the case. The MCP protocol itself is extremely lightweight. As I mentioned, it's a simple JSON schema that provides three things: the name of the MCP server, the textual description of the MCP server, and the schema, or the almost the function call inputs that need to be provided to enable this call. So within this framework, as you rightly pointed out, you should be able to do agent-to-agent interaction as well within MCP. However, as I briefly touched upon earlier, what a lot of these other protocols focus on, which MCP by design does not focus on, are aspects for agent to agent discovery, such as what are the skills and capabilities of agents, what type of tasks that agents can do. How do you search for agents or discover agents in a large landscape of agents? Or how do you authenticate, or how do you trust agents, authenticate agents in a decentralized landscape? So a lot of these other protocols, in terms of the communication layer itself, are also using JSON RPCs like MCP and are very similar, but they build on top of that with all of these other layers, such as trust layer, discovery layer, all of these things that are important for an agent to agent communication standpoint. I think there's a lot of overlap between MCP and all of these protocols, but they build on top of, all of us build on top of each other and take inspiration, but add other important things that people think are necessary for agent communication. The other question was, what does it mean that there needs to be agent to agent communication? Does this not just mean that agents prompt each other? And this is the case in textual agents, that agents would essentially communicate with each other in natural language, and you have to transmit the output of one agent, maybe repackage it in some way and send it to another agent in terms of an input prompt. But agents, you have to realize, can be very general purpose. So agents can be multimodal, agents can have their own tools that they're connected to perform tasks. So it's a bit more complicated than just sending a textual prompt to agents. Agents can have their own capabilities, as Google's A2A standard provides. For example, some agents can be good at medical information. Some agents can be good at CRM. Some agents can be good at chatbots, for example. So you need all of these overheads to figure out what agent to talk to, how to talk to this agent, what sort of inputs to give this agent. But after you resolve all of this, yes, it's finally a text message that goes to the agent to complete that task.
After we talk the general information about MCP, right, now we move to some like a technical protocol design capability piece, right? So the first question would be like, what are the technical components of MCP? How does it enable agents to share and build upon the common contacts?
Yeah, on a high level, there are a couple of important technical components that MCP comes with. First is this idea of a client-server model for MCP. Any MCP, let's call it a service that you connect to, involves two components, an MCP client and an MCP server. And this enables two other things to talk to each other. One is the MCP host, which is like your Claude LLM or your Cursor IDE or any such, let's call it a chatbot. And on the other end is this tool that you want to talk to, like the weather API service that I talked about. So this client-server model of MCP does a distribution of responsibilities where it takes the input from the host, wraps it up in the JSON RPC that I'll talk to you about very shortly. That's what the client does, sends it to the server. The server takes the JSON RPC, repurposes it into function or API calls, gets the response from the function API calls, wraps it into another JSON structure, passes it to the client, and that's how it goes. So the first important technical component of MCP is this client-server architecture. And this is important to note as we'll talk about agent-to-agent interaction, because when we talk about client-server in terms of architecture, there is an inherent hierarchy, because the client is the one invoking the call and the server is the one completing the call. But as we move from LLM to tool interaction to agent interaction, we want to go from a client-server mentality to almost a node-to-node mentality, because anyone can do the calling and anyone can do this. But this is the first technical feature of MCP. The second very important feature of MCP is the JSON RPC format. So this is, I think, the most critical aspect of MCP, because it does what we were talking about up top, which is bring together all of these function calls that exist out there and wrap it in one unified standard format. So all communication in MCP follows this JSON RPC 2.0 format, which enables LLMs to, via their MCP clients, to make a call in a very fixed schema format, where they say what schema format they're following, what's their current version, and what's the, for example, if they want to initialize the communication, if they want to see a list of tools, what tool they want to call, what inputs they want to provide, stuff like that. And this is the same JSON RPC format in which the MCP server talks back to the MCP client for the LLM. This is like a common language that is set up between the host and the API call. And the third is this flexibility of MCP, which is a very important technical component. So MCP works across different transport protocols, of course, via HTTP. So MCP can be used via server-side endpoints, which means you can host an MCP server remotely, or MCP can work over STDIO, which means you can host an MCP server on your local computer and you can talk to it via local cloud. So it's very flexible. More recently, MCP is also supporting OAuth 2, which means a lot of these APIs that require some form of authentication to use them, MCP inherently supports that, another important component of MCP. And moving forward, some important technical components of MCP that are about to come include an MCP server registry for tools that they're hoping to deploy very soon, I believe. I don't have internal information, but this is just as an enthusiast. And yeah, so I believe these three are the most critical technical components of MCP: the client server architecture, the JSON RPC format, and this integration aspects via the HTTP protocol and stuff like this.
In practical, could you explain how the MCP server really operates in the practice? More detailedly, talking about the client server model based on HTTP, they talk to each other, they find each other by using IP address, for example. So my question is, how do these MCP client server each other? And when MCP client want to talk with the server, he need to discover a lot of possible servers around him, and if so, how? Another question is, you're saying that it's a schema standard model. Is it similar to, or is it very different? And how this schema can really guarantee that it can wrap up all the possible function calls?
Great questions. Would love to go into detail of that. So I'll take the first question first, which is how exactly does, let's say I'm sitting on my Claude desktop, how would sort of the MCP flow go, right? How does it work via the Claude desktop? So actually the first question you raised, which was of discovery. So how does my host, which is the Claude desktop, actually find MCP servers and decide what MCP servers it needs to use? To the best of my understanding, there is no notion of discovery in MCP server as such, because there doesn't exist a registry of MCP servers. So how does MCP operate today? I, as a user, need to add a bunch of MCP servers to my host, telling my host that these are the 20 MCP servers that exist out there. So here's the GitHub MCP server, here's the Google Drive MCP server. These all exist out there. So I have to add it. There's no notion of discovery, which means I cannot type into Claude saying, do my GitHub commit, or tell me when was my last GitHub commit. And Claude won't be able to, as of today, find the GitHub MCP server, add it on its own, and then use it via the native MCP servers. I believe they are working on it, as I mentioned, in terms of the registry, which will be very exciting, but this is not native as of now. So first step in using MCP today is adding the MCP servers to the Claude via sort of the config. And what this basically means is I'm actually providing, if it's an HTTP server, then I'm providing the URL endpoint. So it will be usually some kind of /SSE endpoint, a URL that exists out there, which is serving this MCP server. So I'll add it to my Claude. And let's say my Claude has 3 MCP servers that I've added to it, right? Now, let's say those MCP servers are a GitHub MCP server and a Google Drive MCP server. Now, as I mentioned to you, the MCP schema has 3 very critical aspects, which is name, description, and the schema, which is what are the details of the server. And I'll come to you about that, what that means. When I've added these MCP servers to my Claude desktop, my Claude desktop, you can see the names and the textual descriptions. So now when I put in the prompt, which is what's the weather in Boston next week, now the Claude desktop in its system prompt has maybe some component which says, if you need to use tools for things such as this, I recommend checking out the MCP servers that have been added to you and read textual descriptions and see whether any textual description satisfies any of the tools that you need. We'll go ahead and read the textual descriptions of all these MCP servers. I'll see that maybe the weather MCP server is saying I can give you the weather. So first, via this JSON RPC format, it'll send almost a handshake request to this MCP server via its MCP client saying it wants to initialize this contact. If the connection is holding through, it'll get back another sort of message from the MCP server saying, I'll also initialize this contact with you via your MCP client, and sort of the handshake is holding through. The next thing it'll do is it'll send a request for tools. So there's a /tools command that can be sent via the same format. And once it sends this command, the MCP server will return a list of tools that this particular MCP server hosts. In the case of this weather MCP server, it will be, I can give you weather status updates and get you the forecast. And there'll be like a textual description for each of these services or functions. Now, the LLM can decide which one of these functions it needs to call based on the textual description. And then what is the schema in which it needs to provide this input to the MCP server. So the way it works is the MCP server will say it's again a dictionary. And then the dictionary will basically say, I need maybe the latitude and the longitude of the place you want the weather forecast for, and maybe the date. Give me these three things in this particular dictionary format. And then the LLM gives that to its MCP client. The MCP client takes that, and you have to note that LLMs are actually very good at returning results in JSON formats. This is why they're able to do function calls, for example. So as soon as they know what structure of JSON they have to return it in, they're pretty good at structuring it that way. So the LLM will return it to its MCP client. The MCP client will wrap it up in this JSON RPC for MCP, and it will send it to the MCP server. The server will extract the arguments for the function and actually do the function call. It will get the results, again wrap it in this JSON RPC format, give it to the client. The client will extract the essential information from this JSON RPC and give it to the LLM. And the LLM will ingest this information and use it as part of its reasoning. So this is the entire flow of how MCP works.
Yeah, thanks.
And you asked another question, which is, how does MCP ensure that it is general enough in terms of its JSON structure that it uses? And are there any use cases for which MCP may not be sufficient? So actually, that's one of the beauties of MCP. And that's also touching upon the question you asked, can MCP allow for communication? It really can, because it abstracts out entities just in terms of the input that you have to give to them. So you can give an input to a function, you can give an input to an LLM, it's all the same. And the schema for MCP just requires you to give a name, give a detailed textual description, and then you can define what the input-output formats are for MCP according to you. So they don't define how many inputs you can give. They don't define that it needs to be text or image or anything specific. You can define all of that. So that really ensures that MCP is as general as it possibly could be. Are there things that MCP does not do? I think we may touch upon this in a few more questions, but aspects such as security, aspects such as trust, authentication, privacy, these are things that MCP doesn't really touch upon a lot, because MCP assumes that you're operating in a trusted topology. So these are things that MCP is not focusing on as much right now in terms of the communication protocol itself. But in terms of the schema, it's, I believe, as general as it can get.
So I'm sure you did a lot of MCP related work. What are the challenges to leverage?
So there are a few challenges, I think, with MCP as exists today. First, as I touched upon right now, the MCP format itself is very general, but it's upon the builder of the LLM to ensure that the LLM is capable of using the structure. So what does this mean? It means that MCP has a certain JSON RPC format, as I've said many times already, but it has to be somewhere within the system prompt of the LLM that if you have a function, if you have a tool call, then you should try to use the MCP protocol via this JSON structure, and this is how you should talk to MCP servers and so on and so forth. So there is some effort involved in building LLMs that are able to work with MCP. There's some effort involved on the system prompt side to enable this. That's the first challenge. The second challenge is actually, there are two more challenges that I think are very critical. And this I'll touch upon again when I talk about Nanda as well. Related to this, which is that there is a limit to how many MCP servers that the LLM can almost reason across. So as I mentioned to you, when the LLM decides what MCP server it needs to choose, to decide which one to use. It actually needs to read the textual descriptions of each MCP server and decide which one is the correct one. So obviously I can't put in an infinite number of MCP servers in the LLM context, because of course it has a limited context, but also as I start adding more and more MCP servers or the textual descriptions in the LLM's context, it'll start performing worse and worse. It will not be able to choose which MCP server it needs to use to perform its particular task. So I think the most critical challenges of MCP right now are in the orchestration side. And the second part of these challenges are on the security side. As I mentioned to you, MCP relies on the host and the client already trusting each other almost to enable security on this, and it allows for OAuth and stuff like that. But in the communication layer, really it is still susceptible to attacks such as people almost interrupting the HTTPS communication and giving a response faster with a spoofed response. And as long as they can do some minimal work, this is still reasonably possible with MCP because they are not really signed by the communication, not really signed by the endpoints. So there is some trust or security aspects, but it's not really a big issue for MCP or the focus of MCP, as I mentioned, because as I mentioned, MCP is a client server mentality, which means I am connecting MCP servers to my client that I want to use. So that's the mental model that it's coming from.
Since we are talking about security, maybe we can raise the security question first. Client server model over there's only security protocol called HTTPS, right?
Yes.
So you mean that MCP currently don't have this function yet. So do you mean that MCP still don't support the integrated validation mechanism, message signing or content hashing? And then how can we now defend those against adversary agents who want to attempt manipulation, poisoning, or social engineering?
Yeah, great question. MCP spec itself, which means at the specification level, MCP does not require or it lacks this sort of signing and hashing aspect that you just mentioned. However, as I said, the endpoints can very likely decide on their own that they want to sign or hash communication via the HTTPS protocol and then use it between them. The MCP protocol itself does not require it or does not enforce it within the spec. So a lot of the security aspect on the MCP side relies on more of a trusted infrastructure, which means using API keys or OAuth or stuff like this. That being said, there is work ongoing because MCP is starting to, very recently, I think a couple of weeks ago, Anthropic announced support for remote MCP servers. And now MCP is allowing support for registries and search across registries and stuff like that. So I believe they are actually working on adding cryptographic signing, content hashing, and stuff like this within the protocol level as well as part of this open source project. But again, as I mentioned, because this was a very hub and spoke model, it wasn't required from a cloud perspective so much right now, but I believe they are actively working on it. I'm not as up to date on MCP, so I don't know if it's already come out in the last week or so, but at least until a couple of weeks, I believe this was the status quo. But really, I think MCP is moving forward in this direction. That being said, as I talked about, protocols like ANP, ACP, A2A, all of these agent-to-agent protocols put a lot more focus on identity verification, trusted mechanisms, using aspects like DIDs, which of course, as you may know, allows for decentralized verification of identity via public-private key without going to a certifying authority. And so protocols like ANP allow for all of these things like verification. So that's where the field is going. I think everyone is trying to add support for integrity validation, such as message signing. As part of your second question, which is how we can defend against adversarial agents which may attempt manipulation, poisoning, or social engineering, stuff like this. There are a few options that exist out there, but overall, my answer would be, I think this is a broad research problem. Because as we know, LLMs are susceptible to aspects such as prompt injection, where you can provide seemingly almost safe prompt, but this prompt can get the LLM to spew out very sensitive information. For example, I know that I see a lot of this on X, that people try to design prompts that they put in LLMs and then the LLM starts spitting out its system prompt. So LLMs are susceptible to this prompt injection. In terms of how we can start defending against such adversarial agents, First is, of course, authentication. We need to use identity systems like DIDs to authorize agent access and to ensure that there is a base level of reputation or identity to agents or tools that we are talking with each other. There should be a notion of validation. So at some point, we should be able to cross-check shared context. There should be a notion of, and I believe this is an ongoing research endeavor, but there has to be some attempt to sanitize prompts and responses. And every agent should have a security layer. Of course, not just a security layer for attacks from outside, but attacks that are similar to web attacks. But because we are working with LLMs and agents, we have a whole new attack surface over here, such as prompt injection and many other things that are very LLM specific, or hallucination of LLMs, or the fact that LLMs have a non-zero chance of revealing sensitive information, even though they are prompted to not. So there has to be a security layer that needs to be added at every agent that is taking care of all of this. Of course, secure tools and safeguards, which is one of the things that we're focusing on, which is aspects such as trace. So one of the very important things that we believe that will be important as part of this agent to agent landscape is the idea of traceability or accountability. As many hops of agents will talk to each other, there has to be a way to trace back which agent did what and took what decision, to have a notion of accountability, to assign a reputation, and to ensure that agents are incentivized to perform well and disincentivized if they perform badly.
Yeah. This area, I think there are multiple companies working on it, but like MCP, definitely this is something new recently. I do see there are like at least 2 papers talk about the security piece of the MCP, and people are still trying to work on it. Hopefully the 2.0 can solve some of those.
Absolutely.
Yeah. Back to our question regarding the Nanda, because you mentioned there's like a data governance or safeguard piece in the project Nanda. How does it relate to MCP, and how do you guys provide the safeguard from this aspect?
Yeah, thank you so much. So in terms of how Nanda relates to MCP, but not just MCP, all of these things that we talked about earlier, right? Nanda actually, we think of Nanda as a consortium, as a coming together of all the important things that are needed to enable this web. So obviously aspects like MCP, as we've talked about in depth, talk about the communication layer, right? So MCP and A2A talk about how agents will talk to each other. What is JSON format in which one agent should talk to another tool, and what format should the tool respond to the agent in. But there are so many other things that are needed to enable the web of agents. First is the discovery piece. How can agents discover each other in a distributed landscape? Second is reputation. How can we choose between 10 Spotify agents that claim to do the same thing? Which one is the better one to do it? Third is transactions. Fourth is reputation, trace, authentication, security. All of these things are important on top of the communication. So Nanda hopes to be a consortium, very similar to W3C that happened at MIT as well 20 years ago, that enabled the World Wide Web, to enable all of these players that are working on different components of that we think are necessary for the web of agents to come together. Now, one very critical aspect that we are spearheading right now at Nanda is this idea of a registry, a Nanda registry. Many companies already have their own internal agents, like Salesforce has a bunch of agents, Google has a bunch of agents, Microsoft has a bunch of agents, but there are also so many agents that exist out there in the decentralized world, like a small agent for a grocery shop, or a small agent of a bakery shop, or some small startup company that is building agents. So with Nanda, we want to ensure that all of these agents are visible, discoverable, identifiable on this web of agents. And we think the way to do this is via a very core registry piece.
Yeah, that's very interesting. So as you mentioned, once those agents are networked and registered, how does Nanda envision those networked agents participating in shared knowledge building?
Yeah, so I think there are 2 pieces to this. First is, let's say there are distributed agents that exist out there. For shared knowledge building, one very critical component for these agents is to actually find other agents that they need to share knowledge, that they need to learn from, that they need to transact with. So Nanda envisions this piece to happen using the Nanda registry, which is a two-stage architecture that we are proposing. The first is a lean registry that is basically a mapping from an agent name. That could be any sort of agent identifier. It could be a DID identifier. It could be an enterprise identifier, whatever be it, to either an agent endpoint or to what we are calling an agent facts schema. Now, this agent facts schema builds from a very important work that Google built, which I touched upon earlier, which is agent card, but adds a lot of important aspects which we think are crucial for this sort of knowledge building, knowledge sharing, and discovery, such as capabilities, discoverability, routing, uptime, valid endpoints, certifying authorities, trust, all of these things. So we view an agent to be able to hit the Nanda registry, reach the necessary agent fact schema, and then decide whether an agent is good to collaborate with or not, depending on the task of importance. It is also important to note that we don't want to solve all the problems with Nanda. We want to enable the infrastructure and protocol layers that will enable others to solve important problems. For example, we want to be the registry, the DNS of the web of agents, but we are very happy if someone else is the Google search of agents, building on top of the registry to enable fast agent discovery. But we think what the Nanda registry is doing is very critical to enable these services on top of the registry. Now, once agents are able to find each other and build teams with each other, then we think all of these important protocol level aspects come in, like A2A or MCP, that enable agents to talk with each other, share intelligence, and then learn and discover with each other. And then again, as part of the Nanda fabric, we think these agents will also be able to transact with each other, value each other's knowledge or skills, and then decide how they want to assign reputation to each other. So all of these things we think are important in an open, decentralized landscape for the web of agents that we think Nanda is enabling.
That's real cool. Are there like real world experiments or like deployments you can share? Like maybe give us like 3 examples or use cases.
Yeah, absolutely. So I think we already have a bunch of components of Nanda up and running. The V0.1 of Nanda, the deployment that exists out there, we are viewing it as almost distributed. So the Nanda registry, which I said is the core piece, is up and running already for anyone to check. So you can go to the Nanda registry, you can check out all the amazing use cases that not us, but a bunch of other partner companies have figured out to deploy agent resources and tools on the Nanda registry and make them visible on the Internet of Agents. These include aspects such as financial simulations, disease simulations, forensic analysis, drone delivery logistics, education content, and many more important things that are all active agents, resources, tools that are up and running and are discoverable via the Nanda registry. And what Nanda registry and the Nanda fabric enables is for anyone to sign in via an LLM host and talk to any of these agents that are not hosted by us, that are not hosted on your PC, but are hosted anywhere in the world and are discoverable via the Nanda registry. On top of this, we also envision a lot of other applications that we are in the process of launching next 1 week, 2 weeks, including aspects such as how can everyone have their own personalized agents. So how can I have my own personal agent on the Nanda registry and then use my own personal agent to do fun stuff? Can I talk to your agent with it? Can I talk to other MCP servers or some other Salesforce agents and then enable very important and cool applications? All of these being enabled by the registry because the registry is enabling all of these agents to find each other, figure out whether these agents are good to talk to, and then actually doing the conversation. A lot of applications, including a bunch of industry applications like drone delivery, forensics, simulations, but also cool personalized applications like personal agents. Some of these are already up, some of them are coming very soon. So yeah, overall a very exciting time.
I try to understand better how interact with MCP. Do they call to each other or there's like a interface?
Great question. So I think the way we are building Nanda, the way we have built it already is for it to be interchangeable with communication protocols. And this is actually a two-step process over here. First, fundamentally, as I talked about, all of these communication schemas at the low level. So MCP is a JSON schema, A2A is a JSON schema, all of these are JSON schema. That being said, they are not the same JSON schema. There is a difference. And so the way we are envisioning the work is we don't want to be the one to decide the protocol that you should use or someone else should use. We want to be able to support all sorts of communication protocols. And the way we support this via the Nanda registry and the agent facts setup is by actually having an explicit field that enables every agent to say what communication protocol that they want to talk with. So almost like saying, what language should you talk with me in? So the flow is, I find an agent via the registry, its agent facts, I find out what protocol it wants to talk to, and then the Nanda sort of infrastructure allows you to use different sort of JSON RPC formats depending on what protocol you want to talk with, what inputs are required. And this is the sort of structure which the LLM outputs that is given to the node that is then transmitted to the other agent so that it can respond to it. So in short, we really don't want to be the ones to dictate what people use. We as MIT, as a neutral entity, want to just enable everything to come under a unified umbrella, work as part of this open web of agents. And then we believe that in the end, the most efficient, the most useful communication protocol would be the one that is most commonly used. And then that will be the organic way to move forward.
I see. So basically it's similar on top of every protocol. There's a Nanda layer kind, right? Once the agent like connect to your system, there's like an underlying JSON algorithm or something, like a normalize the connections. Agent can go through this layer, talk to the protocol, and then link to the other side of the agent.
Exactly. That's exactly. And it's all very early times, as we all know, right? All of these have come in the past 1 month, all of these protocols. It's all very nebulous. And we are really building, all of us are building very fast to keep track with what everyone else is doing. This philosophy may change in the future, but today it is like this, as a Nanda layer on top of every protocol.
Yeah. How long did you guys work on the Nanda?
It's a great question. Our lab here at MIT Media Lab has been working on problems that are core to the web of agents for several years now, for almost 5 to maybe a lot of years actually. We've been one of the first to build aspects such as AutoML. We've worked in privacy preserving machine learning. We've built data markets. We've built agent orchestration across distributed landscapes. And over the past few months, as we've seen all of these protocols come out, all of these agent to agent having a lot of steam, we've brought together all our expertise, and we've been working on this instance of Nanda for the past few months now. But this is really a culmination of all our work for the past couple of years on the academic side to build all the fundamental building blocks that we think are essential for the web of agents.
As you mentioned earlier, then right now agent is simply text. It typically involved with multimedia, and we know that MIT Media Lab. So has NCP handled currently the multimodal scenario, and have you ever have some kind of thinking about this scenario? Yeah.
It's a great question. So I was talking to you about this Blender MCP, which is a 3D. So short answer is it can be supported. It's a bit difficult and not a lot of people are doing it right now. There are some endeavors towards it. So for example, this Blender MCP server is connecting a Claude LLM to a 3D modeling tool. But it's not really a complete two-way communication yet, because the Claude is able to tell the Blender 3D rendering software that it should generate such 3D renders. But then the Claude is actually not taking in the output or the rendered image of the Blender to actually take some decisions. This is actually a very exciting space. So I come from a computer vision background. My PhD was in computer vision. I did a lot of work in Gen AI, in face reconstruction, 3D generation. So I'm actually very partial and excited about visual applications. But as you mentioned, multimedia has its own challenges. MCP, as I said, I believe there should not be any reason why MCP cannot support it, but it's again up to the host and the MCP server to build support for it, because HTTPS can support multimedia transmission, MCP can support it, the schema can support it, but the host and tools should support it. My thinking is that this is going to be a big thing very soon. Just as we went from ChatGPT, which was a text LLM, to today, all big models are multimodal, right? Like they're all vision, language, and they can do cross-context reasoning almost, cross-modality reasoning. I think this is going to be the case for MCP, but not just for MCP, for A2A, all of these agent-to-agent protocols, and as part of Nanda as well. So I think this is going to be a very big thing, and I'm very excited about it.
Thank you.
Since we still talk about Nanda, right, has Nanda explored methods to ensure agents' behavior is auditable and traceable within shared environments?
Yeah. So the Nanda protocol schema itself has components that we think are required to enable agent auditability and traceability, aspects such as certificates and end-to-end signing, and some other important components that we are building on top of to ensure that agent communication can be almost validated or authorized by the entities who are making the communication. And there is a way to go back and figure out, let's say there was like 5 agents that talk to each other in a complex orchestration to do a particular task. Is there a way to go back to these 5 agents, trace back how they talked with each other, and then figure out who took what responsibility, who took what decision? This is one of the core design tenets of Nanda. I would not say this is a solved problem. We are building on top of it. We are building it right now. It's part of our protocol schema, which is already public. And we are building SDK components. We are building components within the registry. In fact, the registry already has components such as third-party auditing, public-private key signing, decentralized identifiers that we think are critical steps towards enabling traceability. But indeed, this is one of the core tenets of Nanda. And we have built a bit towards it, but there's a lot more work that's happening as we speak right now.
Yeah, thanks. Next question is, how might MCP and Nanda enable open ecosystem where diverse agents contribute to dynamic workflows?
Yeah, so I think this is actually the fundamental, almost design principle of Nanda, right? We want to enable an open web of agents, an open ecosystem, an open market where we are not behind like app stores almost. There's only some agents that do particular tasks, but it's an open market. Anyone can build the best possible agent to do a particular task. And if that's an agent, that's an enterprise agent, that's very great. But if that's not an enterprise agent, that agent should still have the right and the capability to be discoverable and monetizable. So think of it as the World Wide Web, right? I can host my own web page. I don't have to go through some trusted authority or like almost a few authorities that have the ability to host a web page. And my web page is discoverable to anyone. And it's almost a meritocracy. This is what we want Nanda to enable. And the registry piece of Nanda, which is a globally accessible, visible, almost source of truth that anyone can hit, anyone can identify, is one of the critical components that makes Nanda open. Anyone can join the Nanda registry. This can be an enterprise, this can be an individual entity, and they're all discoverable via this registry. And we think this is one of the first components that are required to enable an open ecosystem and enable almost a free market of agents so that almost the sky's the limit for what agents can be. And one of the very important aspects as we build this kind of an open ecosystem or a web is very similar to the World Wide Web. Nanda also builds on top of this philosophy of a distributed registry. Like DNS, there are 13 root nodes. Nanda also has a sort of a distributed registry that is distributed across a bunch of universities around the world. These registries talk to each other, are together the source of truth, and they should be easily accessible from everywhere in the world. Anyone can join it. And we think all of these distributed registry components, as well as this open accessibility of the registry, is going to enable a truly open ecosystem where anyone can contribute, anyone can be discoverable, and anyone has the capability to become the best agent almost to do a particular.
What excites you most about the future of model-to-model or agent collaboration with those protocols?
Yeah, I think there's so many things, right? Every time I try using ChatGPT or Claude, it does a new thing that I didn't know it could. A couple of days ago, I was sitting with my wife and my wife was saying, "Oh, I want a sweet and build me a dessert, make me a dessert." And I had no clue how to make desserts. I just told ChatGPT, my wife wants a dessert, help me. And the ChatGPT gave me like a beautiful recipe that I made in 1 minute. So all of these LLM agents are so good at doing so many things. So there's so much to be excited about. But coming back to be very specific about agent to agent, I think one amazing thing that our group is very excited about specifically is this idea of knowledge markets, right? As we know today, most big LLM providers like OpenAI, Claude, they transact in data. Data is the core commodity that enables these large models to be as good as they are because they're trained essentially on the public web, right? But we live in a world where a lot more information or knowledge is actually not public. It's private, it's siloed, it's within enterprise paywalls, and there's no chance that it's going to ever be public. In fact, the more valuable the data is, the more likely it is to be siloed behind an enterprise paywall and never see the light of day. So we think one of the very important things that agents are going to enable is agents or LLMs can be put on top of very informative databases, and they can transact in intelligence and not just data entities. So for example, very similar to the notion of differential privacy, right? LLM or agents can convey the knowledge or the intelligence within a large database to another entity without exposing individual data entries that the organization may want to safeguard. And this opens up a whole new revenue stream for all of these holders of big databases. So how do I monetize intelligence? How do I value the intelligence that some other company is giving me? How do I figure out that this intelligence is what I want to work with? So all of these very exciting aspects we are particularly excited about. We call this knowledge markets. And it's almost how do I transact a kilogram of intelligence, right? We know how to buy and sell a kilogram of apples and onions. But what is a kilogram of intelligence for LLMs? What does it mean to value intelligence? How do I transact it? How do I evaluate it? This is something that we think agent to agent is going to enable, and it's very exciting.
So just want to confirm my understanding. So what you're saying is when agents work with agent together, they're not only call the original data and push the data to each other with the original way, like a translate or like they summarize or doing some reasoning or something, right? And then they reorganize the information, make it to the knowledge, and then they transfer to each other to make it more efficient, right?
Absolutely. Absolutely.
This is very powerful. Like maybe after they work with each other, something new will happen. Like human didn't even know. I'm glad like in your layer, there's auditable and traceable information. But honestly, this is the part like I feel it's always like a black box in the LLM. You never know how that happened, huh?
I completely agree. I think you hit the nail on the head over there, right? Because when you think about it, it's so powerful, and like they can discover new things, discover new aspects from data sets that we didn't know, transact in that, talk to each other. And as you said, these are black boxes, which is why it's so important to have these protocol and infrastructure layers that prioritize traceability, security, authentication, and build guardrails to ensure that agents are truly doing what we want. Because if you think about it, we are going to move to a space where today agents are almost proxies of humans, right? We write a command on Claude or ChatGPT and it does tasks on our behalf. But very soon we are going to have autonomous agents that are going to act on our behalf without even us prompting it. They're going to talk to other agents, do things, figure out stuff, and have it done without me telling it to do it explicitly. And for such things to happen, there has to be a very core focus on the trust layer and on all of these fundamental aspects of the protocol.
Yeah. That's very interesting. And the reason I just feel like those protocols and layers are important because they have better way to collect the data, right? And the other piece is they can actually leverage the tools. Like it used to be like when we ask ChatGPT do something, ChatGPT will think about it and try to give you the answer from their own, right? Most recent, I think maybe 1 or 2 months, I start to notice they can ask some question. Oh, if you feel slow, do you mind if I open the application or something for you? This is like the web link. Do you want me to navigate to there? I'm like, oh, must be something happened. And I guess it's this protocol helped, to call those additional tools. And now it's like the LLM or like a ChatGPT, they start to learn how to use all those tools, right? Remember, like when we talk about things like how human different from animals, because we can use tools. Now AI can use it as well. Do we call AI like a second people or something now?
It's a great question, right? Goes back to the famous Turing test. When we were building programs, there was this Turing test, which is basically if you keep a computer and a human behind a wall, and the goal of the human is to ask both of them questions, and depending on the response, figure out which one is human and which one is AI almost. I think we are at the stage where our LLMs can beat the Turing test almost in this fundamental definition. So in some ways, yes, you're right. In some definitions, these LLMs are very close to second people, right? But they are very good specific experts. But at this stage, at least, humans have the upper hand. I don't know what will happen in the future.
Yeah, we wrap it. So we wrap everything. So the next question is, MC protocol is wrapping on the function call whatever information data. Wrapping most times like it hurts the efficiency because you have a lot of more informations. So how can MCP handle the kind of execution efficiencies? And also, will MCP wrap sometimes wrongly based on because of a hallucination of others or some information missing something? How can MCP handle this?
Yeah, it's a great question. So a lot of these are actually, let's think about what the goal of MCP is, right? The goal of MCP is to take one agent and one tool and have them talk with each other. Now, this is a very sequential interaction, as we talked about earlier. It's initialized, tools are asked for, blah, blah, blah. We talked about this already, right? It's a very sequential communication. What you are saying is, let's say if an agent is talking to many tools at the same time, or like it's talking to an MCP server that's somewhere else in the world, and that server is very slow, then what can MCP do about this? I think the strength of MCP is that this is truly up on the host and the MCP server designer. It's up to them to decide how they're routing their MCP calls, how they're deciding which calls to prioritize, how to wait, how to schedule calls, and so on and so forth. So this is a software engineering problem on the end of the host and not a protocol issue. As far as MCP, however, I completely agree with you. This is a major problem, especially as we are orchestrating many tool calls, right? I think that's a question of how the host is designed, and it lies within the MCP ecosystem. It lies on the host design to figure out how to do the scheduling. The second question on hallucinations is very important because, again, MCP is just giving a schema, right? It's a JSON schema, and it's up to the LLM to output that exact JSON schema, and only then MCP work correctly. If the LLM outputs a wrong JSON schema with a key missing or something like that, then MCP is not going to work. As I mentioned again, there's a component where the LLM has to be properly told, which means the system prompt has to be correct. Maybe there has to be some fine tuning so that the LLM is reliable at returning outputs in this particular JSON schema format. And then of course there are checks on the MCP client end to ensure that the LLM is returning the correct JSON schema before sending it across to the MCP server. And there are errors that are within the MCP SDK so that the error goes back and saying, oh, you missed this particular key. Try again and give me a good schema that adheres to the MCP schema. And then I'll try to do this MCP connection again. Yes.
So if you try to reduce three things from the beginning of Ananda, what would you do?
It's a great question because this space is moving so fast that so much is happening at the same time that we are all working at the same thing at the same time, basically. So we saw MCP, we started working on Nanda, and then we realized that ACP, oh, there is A2A. So actually, when we started working on Nanda, we were working on all the components at the same time, which is we were trying to build our own protocol, we were trying to build the trust layer, we were trying to build the traceability layer, and so many other things. Of course, the registry and all of these aspects. The core thing that we've learned as part of this, I don't know if we'd redo it if we started Nanda and if we had the same context, but now in hindsight, one of the core things we realized is this really has to be a collective endeavor. People are working on the communication protocol, people are working on the trust layer, we are working on the registry, and we all have to work together. We can't build our own protocol. We all should take these protocols, build on top of each other, and improve each other's work, and then build together. And this is how we are working with the Nanda philosophy right now. We are very happy with MCP, and we don't want to redo it. We actually want to improve it. We want to say, these are the things that we think you should add, and Nanda will do it for you. And then come be a part of Nanda. A2A, we'll support A2A, we'll support MCP, and together we can build the web. So I think the core, I don't know if these are three things, but I think this was almost the one thing that I think is critical, that like we build together, we don't build against each other. And that's how we'll build the web of agents over here.
Yeah, I'm just curious, like when you guys try to integrate all those protocols together, do you guys facing some integration difficulty? Like at the time when you try to integrate, you need to have the authorization from each type of protocol, and you need to negotiate with each company to make it happen? Or?
No, actually, so all of these, the great, amazing part of it is all of these are open source protocols, right? MCP open source. So they're all public, they're being built in public. Really no issue on the protocol. And of course, we have to build on top of it. We have to add stuff that Nanda wants to integrate the registry, support all of these things. So of course, software engineering challenges and maybe some bugs in the protocol because all of these are open source endeavors that work together, but no integration issues because they're all beautifully open source, which is the amazing thing about this space right now.
Cool.
Next question is, do you have any kind of book you want to recommend to AI founders or supporters?
I'm definitely not an AI founder, so I'm sure AI founders have like amazing books, but I'd love to recommend one book that I really liked as every part of my recent journey. One of my friends gifted me this book, which is Thinking Fast and Slow by Daniel Kahneman. He gifted this to me during my PhD, actually, a few years ago when I was pursuing my PhD and almost learning how to think. How should I think about things? How should I think about problems? How should I decide what's the correct thing to do? My friend gifted this to me on my birthday, and that really changed my thought process. And of course, this is a very general thing, right? This book talks about the psychology of how humans think and how we arrive at decisions and how we have confidence in decisions that we take in a certain way, but that may not be the best way to take a decision. So it really tells you how you should think about things. And in my case, I really applied it to research, to what problems to solve. I applied it to how do I work on Nanda, for example. So this is one of the books that has really changed the way I think. And especially in fields like this, in research, in building the web of agents, all of these cutting edge fields, it's not really the how that counts, right? All of us, I'm sure like there are many people who are better at implementing software than me. They can do software so much better than me. What we are really excited about is what is the problem to solve? What is the next big thing? What is the next big idea that should be solved to enable the next big thing? And I think this book really helped me on that path. So Thinking Fast and Slow by Daniel Kahneman.
Thank you so much.
Well, what are the most interesting, innovative, or your favorite AI products you've seen most recently?
Yeah, I have so many answers for this that I don't know how to choose one. The AI products that I use the most are, of course, Claude and ChatGPT. And with MCP, actually, I have started using MCP with Claude to do some integrate with my Google Drive and stuff like that. And like, it's so much fun that I really like. When we started out with MCP, I must confess that I thought this is so simple. Like, what would be the use of this, right? This is just like API calls basically. But as I started using it, and like the magic of integrating like these tools with Claude and with Claude calls it's so much fun that like I think MCP itself is such an incredible tool. But apart from that, as I mentioned to you, I come from a vision and multimedia background. Some of my favorite tools are these like AI video generators, because I truly think that there's this question on what's a world model? What's a model that will model our world? And I think there's a very good argument for generative video models to be a very important component of world modeling. And I think generative video models are extremely exciting because just by modeling videos, they show the capability of learning the physics of our world, which I think is an incredible, fascinating academic problem that I'm very excited about.
That's very cool. Yeah, it's very interesting. Recently, I saw there's a MCP. It's for developer to cook meals.
Yes.
They make an MCP as a part of the project, like how to teach developer cook or something. I think on the GitHub, it's like about 80,000 like stars or something.
Wow, that means
Yeah, I remember
really need to know
80,000. But I said, oh wow. Finally, I understand. Wow, this is a large demand from the developer to cook food. From MCP, they need MCP to understand.
That's so funny. That's true. Developers really want to learn how to cook. And MCP is the way to do it. Maybe I should also try it out because the only thing I can cook is instant noodles. Completely agree.
And we have been asked a lot so much for your great input. Is there any questions that you think you should ask but we missed?
Yeah, I think you guys asked such great questions. I'm so happy to talk about all these with you. Just love this conversation. One of the questions that I love to think about is, because I drew this analogy between World Wide Web and the Web of Agents, we have some number of web pages that exist, about 300 million unique IPs. But one of the questions that I ponder about a lot is how many AI agents will we actually end up having in the next 10 years in this web of agents? Will it be 1 million agents? Will it be 1 billion agents? Will it be 1 trillion agents? There are arguments for all of these. More than 5 billion cell phones out there in the world. Almost everyone has a cell phone. Some people have more than one. And imagine that there can be AI agents deployed on each cell phone. Then already we have an order of magnitude more cell phones, more AI agents than web pages. But think about specialized AI agents. There can be more than one AI agent per human. And really, we could be touching hundreds of billions of AI agents, maybe trillions of AI agents out there. And if this is really the world we are going towards, what are the implications of this? Of course, on the infrastructure side, so how do we build this web of agents? But on the social side, how will our world change if we have trillions of AI agents doing a lot of our mundane tasks? How will jobs change? How will our day-to-day life change? I think these are things that I think about a lot. I don't have answers about, but they excite me and scare me uniquely. But that's also one of the reasons why we are working on this, because these things are so exciting yet scary. We need to be responsible about building these tools to ensure they are aligned with the goals of what we as humans want.
Thank you so much for your time.
Thank you so much for having me. This was a great conversation. Loved your questions and hope this was useful.
That's all for today's episode. Thank you for tuning in. We hope it sparked some inspiration for you. If you enjoyed our podcast, please share and leave your thoughts in the comments. You are also welcome to join our WhatsApp listener group to dive deeper into the topics and exchange ideas with others. Bye.